Hey guys, welcome to the notes for writing point-slope equations. Our essential question is, why are multiple representations important? So the lesson before this is all about slope. So you're going to be talking about slope for the entire Unit 3. Unit 3 is all about lines. And so a line is linear is one of the first parent functions we learned, which is y equals x. So if you want to just kind of write and just kind of remind yourself, oh yeah, I know about linear functions. The linear parent function is y equals x. So the highest degree of a linear function is 1. For example, the highest degree for a quadratic function would be 2. So we have y equals x. Okay, so we have 3 forms that we're going to learn about in Unit 3, and this is the first one. So I'm going to go ahead and I'm going to just briefly write some, actually I'll write down point slope first. So let's talk about point slope, and then I'll talk about the rest of them. All right, so for point slope form, I'm going to go ahead and write that form down. That is going to be y minus y1 equals m times x minus x1. So those are ones, those little tiny ones down there, and then I do have those parentheses. Okay, now what do you notice? Well, I notice that I recognize this variable, and m to me means slope. Right? M means slope, and it meant slope the previous day when we learned about slope. So m is always going to be slope. And then I also noticed that I have a y1 and an x1, which is very familiar to me because when I was finding slope, some of the slope formulas were, y2 minus y1 over x2 minus x1. So I know that x1 comma y1 is a point. Okay, that's a point. I'm going to go ahead and erase this little thing here. So this is a point on my line. All right, now let's talk about the 3 forms real quick. You don't have to write this part down, so you can just go ahead and drop your pencil, but you should be taking notes. But for right now, we're good. All right, I'm going to draw the 3 forms that we learned in Algebra 1 about linear functions. So we have y minus y1 equals m times x minus x1. We have y equals mx plus b. And this one should be familiar because we learned that in middle school. And we have ax plus by equals c. And this is standard form. So we have 3 forms. We have point slope, slope-intercept, and standard form. These 3 forms are going to be in Unit 3, and we're going to be writing with them, graphing with them, using problems with them, so we're going to be using these a lot. So Unit 3 is the very first unit where we're diving into some algebra, some algebra that we haven't learned already. Okay, now I want you to look at all 3 of these forms and tell me what you notice, and tell me what are the 2 things that you see that are consistent and the same in every single form. Okay. Now, if you haven't noticed already, there's an x in each one of my forms. There's an x. There's also a y in all of my forms, right? So all of these forms have an x and a y. They might have different other things, or like they might have other different things, but they all consistently have an x and a y. That's because a linear equation has to have an x and a y, an independent and a dependent variable. So hopefully that reminds us a little bit about we need an input and an output. So those are all going to be similar. So when I'm using point slope form here, let me use a different color. This y and this x are never going to have anything plugged in for them because we need those in our equation so that we could put an input and get an output. So the only times we're plugging in numbers is going to be for the y1, the m, and the x1. All right. You can use this formula to write an equation of any line as long as you have 2 things. Okay, well, this form is called point-slope form. So in order to use this formula to create any line, I need a point and a slope, hence the name point-slope form. So not only can I have a point, I can have any point. So it doesn't matter what point it is, I can choose whatever point I would like. If they give me a bunch of points, I can just choose one. I choose my favorite. I can use any point, and I need the slope. That's why it's called point-slope form. So in order to use it, I have to have any point and a slope. All right, number 1. Write an equation of the line that passes through the point 3, 2 and has a slope of -6 in point-slope form. What form does it want me to write it in? Point-slope form, which means I'm going to need y minus y1 equals m times x minus x1. Now, if you're in on level, then you're allowed to be having, oh my goodness, if you're in on level, you're allowed to have a formula chart. So this formula will be on there for you, so you do not have to memorize this. Okay. Write an equation of the line that passes through the point 3, 2. and it has a slope of -6. In order to write something in point-slope form, what are the two things that I need? I need a point and I need a slope. And lucky for me, the problem already gave me everything. It gave me a point, it gave me 3, 2, and it gave me a slope of -6. And how can I represent slope as a variable? That's going to be my m. So m is going to be -6. Now, I'm going to plug this into my formula. However, I'm going to label my point first. So my 3 is going to be x1, and my 2 is y1. So this should be familiar from the day before when you were labeling your points for using the slope formula. All right, so let's go ahead and plug this in. So remember, your y and your x are always going to stay the same. So I have y, and then I have minus y1, which is 2. Okay, right, we're using this point over here. Equals m, which is -6, our slope. And then I have x minus x1, which is 3. I know I'm switching colors a lot, but I'm trying to keep it consistent to what I'm plugging in. So this is my point-slope form. I have the slope, I have a point, and I plug it into the form. And that's literally it. Now there's one more thing I want to mention before we move on. Notice that when I plug in those numbers, the signs kind of change. So look, here I now have -3, but when I started I had a +3. Here I have a -2, and when I started I had a +2. So what do you notice? Your signs are changing, they're opposite. When you plug in a point to point-slope form, it will be opposite signs. So, for example, if I had -5 and -7, when I plug those in, I would have a +5 and a +7 in those values. Okay, so the signs do change. That's the one big mistake. Another mistake that people like to make is instead of putting the 3 in x1, they put it in for y1 because they're like, oh, it's just easier if I do this. Then they plug in x for the first part and y for the second part. However, when you're in a rush like that, you're going to get it wrong. You want to make sure that we label, right? We label to make our lives easier. So please plug it into the right slot, right? You want to put your x1 where your x1 is, not your x1 where your y1 is. All right, number 2, write an equation of the line that passes through the point -5, 0 and 5, 4 in point-slope form. Okay, so we're given 2 points and we're asked to write it in point-slope form. So I'm going to go ahead and write that formula down again. I'm just writing it so I don't have to go back and forth referencing it. Okay, now I'm given 2 points. I'm given the point -5, 0, and I'm given the point 5, 4. Okay, well, in order to have point-slope form, I need a point and a slope. And it doesn't matter what point, so any point, I can choose either one. However, I'm not given the slope, so I have to find it. Well, I know how to find slope of 2 points. Use y2 minus y1 over x2 minus x1. So I'm going to label my points. And it doesn't really matter which one your points are labeled. So if you wanted to do 5, 4 being your x1 and y1, that also works. There's not a wrong answer for doing that. You would get the same exact thing if you did it the other way. Okay, so let's go ahead and plug this in. I have m equals y2 minus y1 over x2 minus x1. So I have 4 minus 0 over 5 minus -5. You know, when I plug in, I'm always going to use parentheses, so I'm going to go ahead and put those parentheses there. I have 4 divided by 5 minus -5, which is +10, which simplifies to 2 over 5. All right, let's go ahead and try that for this one. So this one, the points are flipped around a little bit. They're not in the same, or they're flipped, right? Instead of having 5, 4 being the second point, I'm putting it as the first point. So let's see if we get the same thing. So I have m equals my y2, which is 0, minus y1, over -5 minus 5, which is my x1. So I'm using the same exact formula, equals, well, that's going to be -4 in the numerator and then -10 in the denominator. And when I simplify this, it'll be a +2/5. So regardless of the way I do it, my slope is still going to be the same. So it does not matter which point is which. All right, now the important part is that I have a slope, right? So I have a slope of 2/5. I know for a fact that my slope is 2/5. I'm going to go ahead and erase all of this. Okay, I have a slope and I have a choice of 2 points. For point-slope form, it doesn't matter what point you pick. You just have to have one of them written in. So let's go ahead and plug in. So one of your possible answers could be y minus, and let's use this one. So we have y minus 0, right? That's our y1 equals m. Oops, I know m. My m is 2/5, my bad. My slope is 2/5, so I'm going to plug that one in. And then I have x plus 5, right? Because when I plug in this negative 5 for x1, I'm going to plug in a plus 5. Okay? So that's one answer you could get. You could also get another answer, which would be, let's use a different color. I don't know what color to use. Let's use this hot pink. All right, I could have y, and I could have minus 4 equals 2/5, and then x minus 5. So this is another answer I could get. What's the only difference between these two? Well, they're points that I use, right? The slope is exactly the same. It just doesn't matter what point I choose. And remember, when I choose my points, make sure your y's are going in the y spot and the x's are going in the x spot. And I'm going to go ahead and graph this in Desmos to show you that they are indeed equal. So I have y minus 0 equals 2/5 times x minus, is it minus 5? I think it's plus 5. Plus 5. And then the second line is going to be y minus 4 equals 2/5 x minus 5. Go ahead and change the color for this one. I want you to look at these two lines as I tap back and forth. What do you notice? They're exactly the same line. Their slopes are the same. However, their points are different, but it doesn't matter. I can use any point on my graph. So, it does not matter what point you choose. Okay? I just need one. All right, number 3, write an equation of the line in point-slope form. Aha, point-slope form. So make sure you read. A lot of questions can just be mistaken if you read wrong. So please make sure you read correctly, or make sure you read the entirety of the problem. All right, you're given f of 1 equals -9 and f of 4 equals -21. Well, f of 1 equals -9 isn't really a point, but it's a point in disguise. So normally we see f of x, right? So if it's f of 1, the 1 is taking place of my x value. So this is my x value, which means I have 1 comma -9. That's the point that I'm given. And the other point would be 4 comma -21. So now I have 2 points. And I can actually find point-slope form now because I just need a point and a slope. So before I can plug everything in, I need to find my slope. So I have my 2 points here. I have x1, y1, x2, y2. All right. I have my slope, which is going to be y1 or y2 minus y1 over x2 minus x1. Okay, and that'll give me -9 minus -21 over 1 minus 4. All right, so let's simplify this. -9 plus 21 is going to be what? 12, positive 12. And then the denominator of -3, and this simplifies to -4, or -4 over 1. And I did mention, remember, that -4 over 1 is the same thing as 4 over -1. I talked about this in the slope notes, but it means the same thing, right? It's just one's a little bit, it just doesn't matter where it is as long as you have a negative in there. All right, so that's my slope, and now I'm going to use my point-slope form. So it doesn't matter which point you use, so I'll go ahead and show you both types of answers. So on my key, I will have a multitude of answers, but you just have to have one of them. So I'm going to use the red star point first. So I'm going to have y minus -21, so it would be plus 21, right? Because when I plug in a 21 for my y1, oops, let me go ahead and write the form down. I forgot to do that. When I plug in the y1, the sign's going to change, right? Because it's a -21, now it's a positive 21, equals my slope, which is -4, times x, and then I have a -4 because my x1 is a 4. So that is one answer I could have. Another answer I could have is using this point. So I have y plus 9, right? Because when I plug in my y1, in this case it's my y2, but when I plug in that y value, it's going to be a positive 9, equals my slope, which is -4, times x minus 1. So this is also another answer I could have. All right. Moving on, we're talking about tables now. So number 1, using the table, write an equation of the line in point-slope form. Well, again, I'm asked to use point-slope form. Anytime I need to do point-slope form, I need a point and a slope. And I have a table here, which means I have a variety of points. Now, there's multiple ways you can find slope, right? Because they didn't give it to us, they just gave us a table. So there's a couple ways you can find slope. You can either pick 2 points and use the formula, or you can do change of y over change of x. I'm going to go ahead and do both here. So I'm going to go ahead and use 2 points first, and it doesn't matter which 2 points you pick. Just pick 2 points to use y1 and to use your slope formula with. And I'm just going to pick the last 2. Why not? So I have 1, 9, and I have 2, 13. Okay, I'm going to find the, I'm going to find the slope using these points. So I'm going to go ahead and label, because you always want to label. It helps your life out a little bit. Okay, I'm going to use my slope formula. 13 minus 9 over 2 minus 1, which gives me 4 over 1, which is just 4. All right, so my slope is 4. And let's check. Let's use change of y over change of x real quick. So change of y over change of x. Okay, well, change of y means I'm going to do my y values first. So how am I getting from number to number? I am adding 4 to go from number to number, right? 1 plus 4 is 5, 5 plus 4 is 9, 9 plus 4 is 13. So my change of y is 4. And then my change of x is going to be what? How am I getting from number to number? I'm adding 1. So I would have it over 1, which just simplifies to 4. So I could also have a slope of 4. So it doesn't really matter what way you decide to do it. But, sorry, I'm just going to I'm redoing this because I like it to be pretty in matchy colors. No. So it doesn't matter which way you do it as long as you do it a certain way, or not a certain way, as long as you do it somehow, not a certain way. There is no certain way, right? There's multiple ways you can find slope, and this just happens to be the easiest way, is change of y over change of x. Now, picking 2 points is not a bad idea. Anytime I forget, I'm always going to pick 2 points. If I'm too lazy to do change of y over change of x, then pick 2 points. And it doesn't matter which 2 points. So regardless, my slope was 4. Now I'm going to pick a point to use my problem with. Well, point slope form, I'm going to pick the point. Now I'm going to go ahead and list all 5 options here. And I would like you to try on your own. But I'm going to go ahead and write the form down. Y minus y1 equals m times x minus x1. Move that down a little bit. All right, so I'm going to do the first point, -2, -3. So I'm going to have y plus 3, because it's my y value, equals my slope of 4. And then I have x, and then my other value is -2. So that would be a plus 2. Right, so that's going to be that one. Okay. Okay, now I'm going to use -1 and 1. So my y value here is going to be a positive 1, so when I plug it in, it should be a -1. And then I have a slope of 4, and then I have x. And then the x value in the table over here is a -1, so it would be a positive 1 when I plug it in. All right, we're going to keep going. I'm trying to find a color that I haven't used yet. I haven't used, I have used red. What haven't I used yet? Dark purple. All right, I have 0 and 5, so I have y minus 5, because that's my y value, equals 4 times x. And then I have a 0. And you could put plus or minus 0. It doesn't really matter to me, mostly because adding a 0 and subtracting 0 doesn't really change my answer, so I don't really care. Next color I will use, let's see, I already used orange. Maybe I'll change this to like a different color. Make it blue? Yeah. All right, so now I'm going to make this orange, so 1, 9. So this would be y minus 9, because it's my y value, 4, and then x minus 1. That's also the answer. So hopefully you're noticing that my slope is never changing. I'm not changing my slope in any way. I'm going to go ahead and use green because I'm kind of running out of colors at this point. And I know I have lots of shades of color, but I would want it to be like a different color. This is y minus 13 equals 4 times x minus 2. So basically, I'm just plugging my x values and my y values. So it doesn't really matter, again, what point you pick, as long as you pick a point. So all of these 5 answers would be correct. Now, number 2 is the same thing. For this one, I'm not going to show you every single answer in the video because that's a lot of work. So same thing as the last problem. I need to write an equation in point-slope form. So I need a point and a slope. Now, I'm going to pick 2 points. I'm going to pick 5, 1 and 10, 3 to find my slope. And that's just because I want to. I don't have to, but I want to. x1, y1, x2, y2. Whoops. So I have 3 minus 1 over 10 minus 5. Make sure I have those parentheses. Okay, 3 minus 1 is 2, and 10 minus 5 is 5. So I have a slope of 5. Whoa. Slope of 5. Or 2/5, my bad. And then I'm going to pick any point here. I'm going to go ahead and pick that first point. I'm going to pick -5 and -3. Okay, so I have my point slope form, which is y minus y1 equals m times x minus x1. And then I'm going to plug in my point. So I want to have y, and then, oops, I forgot to label. So let's go ahead and label x1, y1. Okay, I'm labeling now. So I have my y1, which is a -3. When I plug it in, it's going to be a +3 equals 2/5 times my x minus, sometimes it's a plus, right? My x1 happens to be a -5, so when I plug it in, it will be a +5. So hopefully you're noticing that when you're plugging in your points, your signs are opposite. So for example, if I gave you a random problem, let's see if you can get this. Okay, what's the slope? Well, the slope here is 3. What's my point? My point, now you're either going to say -8, 2, or 2, -8, or -2, 8, or 8, -2. So you're like, it's probably one of these 4 choices. Remember, your x value goes first in your point, right? So you're going to have the 2 part first. So these are going to be not your answers. And then your signs are opposite. So your answer would be this, because it's going to be the opposite of a +2 and the opposite of a -8. All right, so we're going to be doing that when we're graphing. So that's something good to know. But for this this problem right here, it doesn't really matter what point you pick. So I just picked -5, 3. All right, last 2 problems on the notes. Write an equation from the graphs below in point-slope form. Okay, so I know point-slope form is y minus y1 equals m times x minus x1. And I keep doing that for you because, hey, it's good for to have repetition, right? Now, for point-slope form, again, I can have any point and I need the slope. So here I'm given lots of points. I'm given 4 points. And it doesn't matter which point I pick. So I'm going to go ahead and pick this one just because I feel like it. So I'm going to pick that point, which is the point -2, +1. So I've picked my point -2, 1. Now, could you have picked a different point? Yeah, you could have. All right, now I got to find my slope. So I'm going to go ahead and find my slope here. Okay, now for slope for a line, I'm going to do rise over run for my slope. Okay, my rise. Let's go to the next point. So how many times do I have to go up to go to the next point? I have to go up 2, so that's a +2. So my rise is 2. And then I also have to go to the left 1. If I'm going to the left, that's negative. So it'll be -1, which simplifies to -2. So my slope is -2, and I have a point -2, 1. So let's go ahead and put this in our formula. So I have y minus 1, right, because this is our y1, and that's also an opposite sign, whoa, equals our slope, which is -2 times x plus 2, right, because it's going to be the opposite of -2 of our point. So this would be one of our solutions. So you could have multiple equations, so it might not be this exact point, it could be a different point. All right, and this last one is very similar. So again, I'm just going to go ahead and pick a point. I'm going to pick this one over here. That is the point -3, +1. Oops. -3, +1. And so I'm going to go ahead and find my slope now. So my point is going to be negative 3, 1. Let's find our slope, which is m, and we're going to use rise over run to do that. What's another way you could do this? You could also pick 2 points and do y2 minus y1, right? You have 2 points, so go ahead and pick 2 points. I'm going to do rise over run because I think it's the easiest for this kind of problem. So I'm going to go up 1, so my rise is a positive 1. And then I'm going to the right 3, so plus 3. So I have a positive 3. So my slope is 1/3. My point is negative 3, 1. So I'm going to go ahead and use this. So x1, move this down. Oops, the I. Oh my gosh, there we go. All right, I'm going to label x1, y1. So I have y minus 1, because my y1 is a positive 1, so it's now negative, equals my slope of 1/3 times x plus 3, because my x value is negative, so now I plug it in, it is positive. All right. So point slope form is the first form. Sometimes we do have a little bit of trouble with this because it's kind of a lot of rules and stuff to remember. If you have any questions, please let me know, and I will be happy to help.